All right, so exam one's coming up. So I'm gonna try to spend today and maybe tomorrow reviewing for the exam. If I can, I'll also start the Excel stuff. But if not, we'll save that for next week. So you will need Excel working on your machine. Let me know if you don't have one, because if you can get it for free using, or you can get a what's it called, OneDrive set up using your school email, which gives you like a terabyte of online storage, but it comes with Microsoft Office, all that stuff. So you should be able to install Excel and all that, Word, etc. If you already have it, great. If you want that terabyte of storage, I mean, I would recommend looking into it, and we can talk about it later. But you will need Excel for the next assignments. So anyway, let's start the exam one review. So let's go over I had a few questions students ask about the dimensional analysis section. So let's do a few problems from the homework. I'll do the first two, I guess. Okay, there's one person here. Oh, she said, okay. Go ahead and do a couple of questions from here, and then I'll move on to the review, and I'll publish the review exam that you can take. All right. So on the practice problems and derived dimensions, we had the dimensional analysis part, which basically what they want you to do is show or derive the formula. Show that this is indeed E. That's what they want you to do. So let's go ahead and do that. So left-hand side, and then we have the right-hand side. So in the homework, what I want you to do is just write down what is on the left-hand side. So literally, we have E, right? Then on the right-hand side, you have this equation stuff. And what I want you to do, yeah, that's fine. The question's fine. Is basically figure out how do I get to E. So you have M times V on top over T times L over T. Okay. So I don't know if I have enough space. I'll just go downward for this question. Okay, so what you need to know is what is the where is that sheet? Here it is the table for derived dimensions. So let me share that with you. Okay. All right. So here's volume. Here's velocity, etc. We just got to make sure what do we need. So you're going to substitute using this stuff here, these equations, or these equations over here. All right. So you're going to have this with you while you do this portion of the homework. And you have to be careful, capital V or lowercase v. Lowercase is velocity, capital is volume. Okay. So please have that handy. And then let's look at this question. So this was lowercase v. Let me double check. Yes. So that's lowercase v. And I want everything to cancel, leaving me only with E. So like, is this indeed equal to E? All right, so first of all, L is going to be here, your length, right? So L over T, capital L over T, should be velocity. So right away, you can replace this guy with V. But before we do anything, we should probably figure out what is E as an equation, right? E, I'm gonna write it over here, is technically equal to F times L. Okay. So we need to getting it in terms of F and L should get us there. So we gotta figure out, okay, well, what is F, right? So let's make a note over here. We should know that F is equal to MA, right? So what is acceleration, right? A, that is technically L over, sorry, I'm just gonna put in the wrong units. Should keep it in terms of L. That will be L over T squared. So right now we have L over T, and we have a T there. So if we multiply through, this will become T squared, right? So let's go ahead and do that, because now I see a path. So first trying to analyze the equation for E and figuring out how can I make this crap into E. We'll look at this formula first and then break down the F. So this is the idea I came up with right now. Okay, so this would be M times V times L over T squared, right? And then we know that A, oh shoot, I put A back so I better not. Sorry, my phone distracted me. M. So we know that M L over T squared is going to be A, right? So we can just change that to okay. One moment. I'm getting spam. All right, so here we go. Let's see if this works out, this approach. So we change the A. That's this one here. We have the A now. And we know that M and A is F, right? So let's see if this works. So this should be M times A times V. It should be F times V. Let me double check my formula here. Capital E. Okay. Make sure I wrote my question right. M times V over T, L over T. So this comes in. This gives us A. So everything is right. I don't have L. This is going to be lowercase v. So this should be L over T, but shoot, it doesn't seem to be equal at all. Maybe there's a typo there.
I think you could try to, like in the second step where you have that first equals, you could have M times V over T squared times L over T squared. And that L over T squared would be V, I think, right? Like if you decompose that.
How about these two pieces?
Yeah. I don't know if you could do that, but.
I mean, I can separate, but I can't put the T squared on both. It'd have to be on either or.
Oh, okay.
Yeah, it's not like addition where you can separate it. So currently, I don't see how this V would become an L, and nothing cancels here. Um, yeah, I was trying to think. This one might be messed up. Hmm. Was this part of the homework questions, right? I'm trying to remember.
Yeah, it was the first one on the
And
homework questions.
did you guys see? Were you guys able to solve it? Because apparently it looks like.
I wasn't, so I started on this one and someone messaged me in the class and we were having problems with uh
Yeah, I
just
think.
this paper in general. Like I couldn't get past the first one.
Yeah, I think the first one might be screwed up. But there's no way that's gonna work because this should be. Yeah, this V shouldn't be there. If it was just M over T, then you'd be fine. Because let's see here. Number one, n times V. If it was M over T, we would get MA, which should be F. So we would have to have, this would have to be an L for this to be true. I'm thinking maybe it's F'd up. So on your homework, I would change that to L here. That is the only way this would work. Did you guys try any of the other ones? Would any other ones mess up? Or did you just stop there?
I didn't try any other ones.
Okay. Yeah, I had a few people ask about these, so I want to go through it and check. Okay, so MA3, so then, yeah, because if we do it this way, then it actually works. There's no way it's going to happen otherwise. Because it needs to end up at E. But the idea of these questions is basically, can you derive the formula using all the equations? That's what we're trying to do. But I'm sorry, that one was a little effed up there. Let's check the second one and see. One of my engineering friends made this homework, so now I'm wondering if there's something wrong with it. Number two, P is equal to A times T squared over F times L. So the dimensional part, okay, so left-hand side, just write the P. Right-hand side, let's see what happens. That would be A squared, or A times T squared, over F times L. And capital or lowercase, that's lowercase p. All right, so let's look at the equation for lowercase p. This is technically equal to f over a, capital A. These are important. Capital A. There we go. All right, so we want to figure out how I can make this into capital F over or A, right? So first things first, let's break down, let's separate the pieces. Maybe that will help here. So we know that F is MA, so let's start with that guy, right? And we can cancel the A's now. So now we're left with T squared over M times L. Now, we know F is MA. Capital A is going to be L squared. Okay, little m should be just math. Shouldn't be anything weird. Let me check. Okay. Let's see. There's no other s. Okay. Lowercase a t squared. Let's try a different route. Before I convince myself it's also screwed up, it's got to be another route. Let's say we don't cancel that. Little a is technically what? If we look at our formulas, little a is L over t squared, right? Okay. And capital A we wrote down. So let's see if that helps with any. Okay, so so I'm gonna try this out, see how it goes. All right. So currently, it appears that these t squares will cancel. Let's see here, t is lowercase t, correct? I'm starting to doubt reality now. Let's see here. Question 2, a t squared over f times All right, so that's not good. Alrighty. The same type of thing is going to happen in the years. I'm going to lose the t squares, and then I'm going to lose that L, which will leave me with 1 over F. There will be no A if I go this route. Can I force? If we need to get more clever, then perhaps I'll have to do some math shenanigans. Because using the formulas right now, so far, it's not working. But we know what F is, right? And the F needs to be on top. So if I multiply the top and bottom by M, this will become an F. And we'll go from there. So I'm going to just try this out. So right now, it's not seem to be working for me. So I introduce the M on the top and bottom, right? So now this will be F times T squared over M times F times L. Okay. So now I need an A. So let's see what we can do. F technically has, here we go. F is technically M A. All right. So this monstrosity takes us. This would be M squared, and A is technically L over T squared. See how this goes. That T will up top. I'll get my L on the bottom. And which is how will I get just a P? I don't know what's wrong with this number. I'm sorry, guys. Seems there's something wrong here. A L over T squared. Which I'll put here. But then I'd get a T fourth, which does not help anybody. That does not cancel a single thing. Everything's written correctly. You know what? Since we only have a little bit of time, I will go over these later. And if it turns out they're all messed up, I'm just going to get rid of it. But let's get to the final exam review, because this might be lowercase p, but on the thing, it's, it might be capital, but they have lowercase, which changed the whole damn thing. It's really bugging me now. So because it's capital P, this is capital P. This would be E over T. And E is F times L. Yeah, I'll let it go. Sorry. I'm say sorry. I really want to keep doing it all day long, but we'll have 30 minutes. So let's move on to the final, the actual exam one review that I'm going to post today.
When is the exam happening?
I'm going to let you do it anytime you want. So I'm going to open it today, and I'll let it stay open all the way until Tuesday. So you'll go into your modules and you'll see an exam module, exam one. And you'll see a review, and you'll see practice respondents and make sure your stuff still works. And then you'll upload, you have a section to upload your handwritten work.
You said that's for the review?
No, that's for the exam one, but review is in the same section. Here, let me show you how it looks. It's not ready yet, but you'll see this on your end soon. Here, give it a rough draft for now. So I'm gonna unlock this module as soon as class ends, and this right here will be just to test your stuff still works. So you'll take a practice quiz and make sure you can, actually take it. And if you can, then you're ready for exam one. Of course, I want you to review first. I want to do a few of them from here right now, as many as I can today and maybe tomorrow, maybe Wednesday too. And once you take this, then you feel like you're ready, you can go ahead and take this guy. So I'll put a couple of attempts on here. But the actual exam, when you finished it, I want to see all your steps and how it works. So you're going to upload it here. So I'm going to have these unlocked until next Tuesday. Okay. Any questions about the exam before we start more review stuff?
That makes sense to me.
Okay. All right. Let's just do a couple here. Okay. So you have a table like this. So let's go over the table first. And then say, you know what, here's standard notation. And then they're going to ask you just put in scientific. So these I won't require actual work. Because I mean, it's really just, you know how to put it in that form, right? So I can't really do too much partial credit on these guys, but
Question 2, you'll have 8,500 joules, right? Then they'll ask, okay, what's the scientific notation? So you'll pick a multiple choice option for the first box, which is going to be here. If they go, well, it should be 8.5, right? And then you have another box, and they'll say, all right, well, what's the power of 10? Should be power 3. Move your decimal 1, 2, 3. So that's how you answer the question. And over here you have another box, and you say, all right, what's the multiple choice for this guy? And you'll say, well, that's 1,000 joules, so it should be 8.5 kilojoules. So you'll put the 8.5 there. Okay, so this is pretty much what you'll see for one of the questions. 8.15 meters. Well, you're going to put that in scientific. So 1, 2, 3. So here's the box. 1.55 joules. So 1, 2, 3, right? So this is going to be, hopefully it's not too bad. Meters. So it's -3. So we should know that's going to be million, right? So you'll put 1.5 millimeters. So that's question 2. Question 3 is another table, but this time it's converting different temperatures. So you'll have a chart with Fahrenheit, Celsius, Kelvin, and Rankine. Okay. So we give you the Fahrenheit for this guy, and you have to convert it to each of these. Okay. And then they'll give you, let's see, the next one will be, let's say they give you a Kelvin one. Okay. So you have to convert this guy to these 3, and then this Kelvin to these other 2. Okay. All right. So all we need is our formulas. So I'm going to go grab those temperature formulas. Okay. Okay. So for here, let's work on the 300 first, right? To get it to Celsius, we got to use this formula here. So Fahrenheit to Celsius, we take the Fahrenheit temperature. We plug it in here. Temperature of the Fahrenheit minus 32 times 9/5. Okay. Again, this is not I know it looks like functional notation, so be careful. This means temperature in Celsius. So that's what they're trying to say. Temperature of Fahrenheit. So the Celsius answer would be the 300 minus 32 times the 9/5. So that would get us to Celsius. Grab my calculator. Okay. 300 minus 32 times 9 divided by 5. That should be about 482.4 degrees Celsius. So you put that here. 482.4 degrees Celsius. Okay. Now, to get to Kelvin, we can use this formula. For temperature in Kelvin, all you have to do is take the Celsius and add 273. Okay. Make sure I'm still on the camera here. I'm clicking. Okay. So we have the Celsius, so that would be 42.4 plus 273, which is going to be your Kelvin.
Do we have to remember all these formulas, or could we like write them down?
No, you're allowed to bring a formula page front and back. Whatever you like on there. Okay. All right. Double check my work here. You guys have any questions so far about the review questions? All right. We're good. Okay. One moment. Fahrenheit to Celsius should be if it's 32 degrees, it should not be bigger. It should be 1 second. There it is. Okay. -300 minus 32. Ah, here it is. Like any of those an error. This is going to be 5 nines right at the end. So for your formula, make sure this is 5/9. Yeah, that was way too big. There we go. So 5 nines. That would be okay. 300 minus 32 times 5 nines. There we go. So this is 148 point. We'll say 89, I guess. So then here, now it's good. Okay, so that will be 148.89 degrees Celsius. So over here, you'll just plug in. So this formula is good. This will be 148.89. Okay, plus 273 should be 421.89 Kelvin. So when you're going to Kelvin, you need the Celsius. When you're going to Rankine, you can use Fahrenheit. There we go. You guys all right so far?
Yeah, I'm good.
Okay. All right, so the final one is Rankine, right? So the formula we need for that guy is simply this one. So to get to Rankine temperature, you should simply add to the Fahrenheit plus 460. Okay. So we have currently 300, right? Plus 460. So that'll be what? Yeah. Rankine. Okay. So each of these sections will be so many X amount of points. You gotta make sure you fill out the whole chart. Okay. All right. What's that? I didn't catch that. Yeah, all I heard was static. I think somebody said something. All right, I'm gonna move on to another question. This is, you'll be similar to the rank, find these other pieces, right? So if you had the K, if I want to go to, you would first go to Celsius because you can just subtract, right? Yes, this is number 3 from the review. Okay, so let's move on here. So just for fun, right? We do know that if we add 273, we get the Kelvin, right? So if I subtract 273, we would get the Celsius. So what you can do is just take 144 minus 273, and you'll get the degrees Celsius. And then use your formula to get Fahrenheit, right? Let me go ahead and write down that formula before we move on. So Celsius to Fahrenheit. So I want to get to Fahrenheit, then I use this guy. So multiply by 9/5 and add 32. So we would have negative 129 times 9/5 plus 32. That would be 200 negative, of course, 0.2 degrees Fahrenheit.
Should it be 5/9, not 9/5?
Double check, because yeah, I'm now paranoid too. We're going from Celsius to Fahrenheit, right? Yeah. This one is 9 fifths. This one's 5/9. So this one's good. Yeah. So I think when I wrote the formulas in the notes, when we talked about this, I wrote 9 fifths on both by accident. So on your notes, you might have a 9 fifths here on the formula. Okay. Anyway, let's move on to something else. Unless you guys have questions about the temperature stuff. Okay. Number 4 is pretty chill. Calculate the volume of a box with dimension of length equal to 0.43 meters, width equal to 2.15 feet, and height equal to 38 inches. All right. Give your answer in feet cubed. So here we have to be careful with all the units, right? Because we have 3 different types of units. So there's no way we can start until we convert accordingly. Let's find the conversion sheet. No. Okay. So let's write our conversion factors, right? We know there is 1 foot in every 12 inches, correct? So we can convert this guy. Then we also need to note the unit for meters to feet. Let me find that one. I'll write it down. So 1 meter is about, we'll use this round off here, 3.28 feet. So currently we want to get to feet cubed, so we need to change everything to feet. So I need to cancel inches, I need to cancel meters. So that's the goal. So I'm going to put the feet. So, and also we need to remember that we know volume is equal to length times width times height, right? That's not a big deal. So what I'm going to do is put the length, the width first, because I'm not going to mess with that. Feet. And I'm going to put the inches next, just because, no real reason. And the meters last. So I want to cancel that first. So the conversion factors I'm going to need using these two is these two here. So let's go ahead and write this over here. 2.15 feet. Okay, so if I divide both sides by this here, I know that there is 1 foot for every 12 inches. Right? I know there is 3.28 feet for every meter. I'm going to use those conversions to cancel. So multiply by the conversion factors, and I put feet on the top because I don't want to cancel feet. I want to cancel inches. So I put it on the bottom. And I want to cancel meters. So I'm putting that here. Conversion factor, which I got from here. 3.28 feet over 1 meter. So on the next step, inches will cancel, right? Meters will cancel. And I'm left with 2.15 feet times 38 times 0.43 times 1 foot times 3.28 feet. So now I have feet times feet times feet, which will give me feet cubed. So just multiply all this nonsense and we're done. I don't need to put that one there, but who cares? So this should be a volume of 115.23 feet cubed. Is there any steps that don't make sense? You guys get the idea, right? We bring the conversion factors in to cancel any units that they don't want. They wanted feet cubed, so that's why we took this route. Okay. Alrighty. What is the due date on homework 3? Yeah. Let me check. The 24th. Yeah, it's due on the 24th. Wait. Extend that going. Yeah, so for the homework, all I want you to do is merge all those PDFs that you saw them all on paper, or if you print them out, solve them on there, it's fine too. And then just scan them into one PDF and upload it where it says homework 3. Using the ones all the PDFs I sent you, but that one that you're having issues with, I need to look over and decide if I want to remove it. That's on homework. That might be homework 3, I think. Let me check. Or is that 4?
Sir, homework 3 is actually closed, so we don't have the option to submit the homework.
Yeah, I just reopened it for you right now. Did it contain the derivation stuff?
Yes,
Yes,
that's what was on there.
Yeah, okay. Since there's been issues, I'll remove the due date and then let me look over it. That one sheet. If it turns out it sucks, then just turn in the other 2.
Okay, so I see like the conversions one, which is it was supposed to be a part of homework 3, but we didn't really turn that in because the derived dimensions.
Okay. You're turning the other 2?
I see the conversions, and then I think there's another one that. Let me check. The other one was solving equations. It's 7 solving equations.
Okay, so it was just 2 sheets.
I think that's what it is.
Let me find it. I sent it on.
And then he also sent like homework 4, which homework 4 is like 6 different like pages.
Yeah. Yeah, I think it was 4 was like a little longer, and 3 was about 2 or 3. Let me find it. There we go. Mm, there it is. Yeah, it was just the 2 PDFs. So if I remove the 6, then just do the equation part. But I'll let you know tomorrow. In the meantime, I guess continue homework 4, and I will open your review test at exam 1 as well. So we'll continue Wednesday and try to finish all the review stuff. That way you have some examples, because I think more examples would be good before you go in there. You guys have any other questions?
So you just want us to pretty much like skip past 3 for now and start working on 4?
Yeah, just hold on. The only thing I really want you to do is the equation stuff for now.
Okay, got it.
Okay. All right. All right, guys. So I'll email you guys tonight or tomorrow, but also I posted that extra credit assignment. I don't know if you've seen it yet. Do it as soon as possible. I'll give you probably 5 or 10 points on the exam grade. Okay. And since the school is forcing you to do it, I figure I can give you something. It is due on the 12th. It's at the top of the welcome page or the welcome module. All you have to do is download the PDF, fill it out, and re-upload. It doesn't matter if it's right. Just give it your best shot. It's just the school wants to test out, I think, quantitative skills or something. So it's not necessarily related to this class. It's just something they want you to do. Okay? It's called I guess.